Hey grade 12s, today we're going to look at angles and polygons. So, we're going to look at all the different types of polygons that we see. So, let's go ahead and do that then. Let me grab my magic pen and let me do a little bit of a focus thing. If we're looking at a three-sided polygon, we're talking about the mighty triangle. There's many different types, but a general four-sided polygon is named the quadrilateral. If a polygon has 5 sides, we call it a pentagon. A 6-sided polygon is a hexagon with 7 sides. We use the title heptagon. The 8-sided polygon, most notably seen as a stop sign, is the octagon. The 9-sided polygon is called a nonagon. When a polygon has 10 sides, we call it a decagon. And for those of you who like a little bit of trivia, a 12-sided shape is called the dodecagon. Any of those polygons could be regular. What does regular mean? A regular polygon is one in which all the lengths and all the angles are the same. All the lengths and all the angles are the same. You probably are only familiar with a regular triangle, which we would call equilateral, or a regular quadrilateral, which we would call a square. And you know squares. What about the sum of the angles in a polygon? So if we take a look at a triangle, what do the angles add up to in a triangle? What do they add up to? Well, any triangle, no matter how you draw it, what do the angles add up to? Well, the answer is 180 degrees. Any triangle, angles add up to 180 degrees. Now, can we use that to find the sum of the angles in a quadrilateral, a 4-sided shape? Well, yeah, we can. Because what we can do is draw a diagonal which creates this triangle and that triangle. We form two different triangles. Interesting. So when we have one triangle, the angle's up to 180. With a quadrilateral, by drawing a diagonal, we have two triangles, and the angles, well, it's going to be two 180s. What's two 180s? In other words, what's 180 and 180? What's 360? In fact, if you look at pentagon, well, you could draw three triangles in a pentagon. So that'd be 540. Hexagon, you could draw 4. That's 720. Heptagon 5. That's 900 degrees. An octagon, you could draw 6. So that'd be 1080 degrees. And if we had an n-sided polygon, the number of triangles we can make is always going to be n minus 2. And the angles, the sum of the angles is always going to be 180 times n minus 2. That's the sum of the angles in any polygon with number of sides equal to n. N can be any number. Okay? So this is what this says right here. Sum of the interior angles of any polygon with n sides is 180 times n minus 2. If you have, this is a big if you have a regular polygon, then every angle is going to be 180 times n minus 2 all divided by n. Okay? Example, find the measure of each angle, the quadrilateral below. So we have a quadrilateral. Because it's quadrilateral, we know that the angles are going to add up to 360. So we know that all those angles there add up to 360. So 6x plus 9 plus 6x plus 7x plus 4x plus 6 is equal to 180. Adding that together, we get 23x plus 15 equals 180. 23x is equal to 165. I get 165 by subtracting 180 by 15. Figure out what x is. I'm going to take 165 and, oh, my bad. I guess you can't help me. You can't scream this out to me. But I need to make some corrections here because quadrilateral adds up to 360. My bad. Let me fix that right now. I'm so sorry about that. So this is 360. And when we subtract 15 from 360, we get 345. 345 divided by 23. X equals, what's 345 divided by 23? It's 15 degrees. Lots of times when we find x is our answer. But this question isn't asking us to find x. It's asking us to find the measure of each of the angles. So we have to plug in 15 for x and figure out each of these angles. One of the angles is 6x. That's 6 times 15, which is 90. So that angle is 90. This angle over here is 7x. That's 7 times 15, which is 105 degrees. Down here, we have 4x. That's 4 times 15 plus 6, 66 degrees. 4 times 15 is 60, plus 6 is 66. And last but not least, we have 6x. Oops, I didn't mean to do that. We have 6x plus 9, which I'll just do over here because I don't have much room over there. So that's 6 times 15 plus 9. Which gives us 99 degrees. Okay. So that's how we find the measure of each angle, the quadrilateral below. Okay. Moving on. The sum of the exterior angles of any polygon with one exterior angle at each vertex is 360 degrees. The measure of each exterior angle of a regular polygon with n sides is 360 over n. What the hell does that mean? Well, what it means is, let's say I have, I don't know, let me have a pentagon. Not quite a regular pentagon, but just bear with me. If I was to, I'm a little bit off here. I'm going to draw, continue. Okay. This angle, this angle, this angle, this angle, and this angle are all exterior angles. And all those exterior angles, no matter what type of polygon you have, will always add up to 360 degrees. And if you have a regular polygon, then you can find, then basically all those angles would be the same. And to find the measure of those angles, like if it's a pentagon like this one is, n is 5, because there's 5 sides. To find the measure of each of those sides, you take 360 divided by 5, and that's what each of those angles is. Okay? But how about if the question we get is this? The measure of an exterior angle of a regular polygon, 60 degrees. What's the name of the polygon? And find the measure of the interior angles. So we know that the angle is 60, and that's equal to 360 over n. So what we want to do is we want to figure out what n is. So this is an equation. So we could put 60 over 1, and when we put 60 over 1, we can cross multiply 60 times n equals 360. To figure out what n is, take 360 divided by 60, and n is equal to 6. So this shape has 6 sides. The name of a 6-sided regular polygon is a hexagon, and the measure of the interior angles. So this doesn't want the sum of the interior angles. This wants what's the value of each of the interior angles. So to do that, we're looking back at that formula right there, 180 times n minus 2, all divided by n. So it's 180 times 6 minus 2, all over 6. If you figure out what 6 minus 2 is, it's 4. 180 times 4, 720, divided by 6, it's 120 degrees. So every angle in a hexagon, in a regular hexagon, has a measure of 120 degrees. Okay? All right. Need you to do me a favor. Okay? I need you to do me a favor. I want you to write down some numbers for me, please, okay? Those numbers are I want you to write down are numbers 10, Number's 19, number 25, and number 31. I'm going to hand out, well, I guess I won't be handing out because I'm not there, but you'll be getting a homework package or a sheet to do some practice questions on. Don't do those questions. They've got letters in them. You get silly algebra stuff, so don't do those questions, okay? They'll just frustrate you, so skip them, please, okay? 10, 19, 25, and 31. Just skip those questions, okay? I want to do, I'm going to do number, I'm going to do questions 14 to 18 are a little bit tricky. So this would be a good opportunity to get the assignment handed out to you. And I'm going to do number 14 with you right now to give you heads up on how to do it. So let's take a look at number 14. So you're going to have to write this down somewhere where you got room. Number 14. Says that we have a regular polygon. All the angles are 144 degrees. Find the number of sides. So here's how we do this question. To find out knowing what each interior angle is, trying to find n, we use the formula that 144 is going to equal 180 times n minus 2, all divided by n. So for numbers 14 to 18, there's a little bit of algebra in them. That's why I'm doing this question with you, so you get an idea of how to do it. So what you have to do is cross multiply. When you cross multiply, 144 gets multiplied by n, so you're going to get 144n is equal to 180 times n minus 2. Nothing gets done with what's on the left side, but on the right side, we use the distributive property to multiply 180 by both of those. So we get 180 times n, and then we get minus 180 times 2. Now if we multiply 180 by 2, we get 360. So to do this question, we have to solve for n. How do we do it? What we want to do is we want to do a switcheroo. The switcheroo is going to be, we want to move that to the right, and we want to move this to the left. Remember that when things go across the equal sign, signs change. So negative 360 becomes positive 360 when you move it to the left. 144n becomes minus 144n when you move it to the right. 360 is still 360. If we take 180n minus 144n, we get 36n. And now, to solve for n, we take 360 divided by 36, and we see that that gives us 10. So the answer to number 14 that asks the number of sides of the polygon is 10. Okay? And I want to back up one more step before I let you go. Earlier, I said to skip these questions. You do skip them. But I forgot one question, and I just looked at it now. Number 30. So don't do 30 and don't do 31. So skip those 5 questions. The rest of those questions will be worth marks.